So this is our first Vcast for meteorology, and in this one we're going to look at just the basics. What is the atmosphere, and what parts are we going to have to focus on when we look at meteorology? So first off, the atmosphere is just that layer of air, that very thin layer of air that surrounds us. And when we want to look at what it's made out of, all right, a lot of people just say it's made out of air. Well, the air is made out of different elements and compounds. And 99% of it is actually two things, nitrogen and oxygen. All right. That last 1% are a bunch of different trace gases. Argon is the most abundant. Hydrogen, carbon dioxide, water vapor, and other gases. Those are just a few. But let's take a quick look at water vapor, because a lot of students will question that. It actually varies depending on where you are. Percentage wise, it can be as low as near 0%. So think of the desert. All right, in the desert, it's obviously very dry and there's not a lot of water in there. In fact, this is the Atacama Desert in South America, the driest place in the world. I think it receives less than 0.04 of an inch of rain annually. But it can also, in local regions, vary upwards of 4% of the atmospheric composition. And this is the wettest area. I can't remember exactly where this is, but this is in India somewhere. And I think it averages over 300 inches of rain annually. So that can change. Water is also really interesting because it's the only substance that exists in all three phases of matter. At least the three that you know of: solids, liquids, and gases. So your solids are obviously your snows and ice. The liquid is the rain, and the gas is the water vapor. And this is actually very important when we get into heat transfer and why there are clouds and how they rise. Carbon dioxide is another important gas that can change and vary. Both of these things, the carbon dioxide and the water vapor, are greenhouse gases. They allow the atmosphere to trap in some of that energy and doesn't just release it all back out into space. Other than just those gases, all right, there's also dust particles of salt and ice floating up in the atmosphere. And these are actually really important when we talk about how clouds form. So they aren't something that we can just blow off. All right, so the atmosphere. The atmosphere is actually layered. And if we look at this picture, we can actually see different colors that are representing the different layers. You can see those clouds pretty much stay right in that red layer. And then you have a yellow layer, and then a white layer, and a blue layer, and then so on up. These are the actually several of the lower layers of the atmosphere. We're going to start at the bottom at the troposphere. And the troposphere is somewhere around 0, obviously starting at the ground, to upwards of 15 kilometers. All right, it varies where you are, but the sizes aren't really that important. What we're interested in was made out of what we find inside these layers, and mostly nitrogen, most of the oxygen, and almost all the water vapor is trapped in this very thin layer at the bottom. And it's the most important layer to discuss when we're talking about weather, because it has all the weather, and that includes all of the rain, thunderstorms, lightning, and the snow, and the tornadoes, and even all the hurricanes. All of this happens within the first layer called the troposphere. So this is really the layer we're going to focus on after this Vcast. The next layer up is also pretty important for us. It's called the stratosphere. And the stratosphere is important because it contains the ozone layer. All right, most of the ozone in our atmosphere is found here. And once you finally get up to the top of the stratosphere, now stratosphere is actually where, if you take a commercial flight somewhere, you're probably flying in the stratosphere. 90% of all of the mass is in these bottom two layers. And the reason why you get that pressure, or that the effect of this, is that we can feel a change in pressure as you go up in an airplane, or if you drive through the mountains. As the higher you get up, you have to pop your ears. And that's because there's less and less mass above you, which means there's less pressure pushing down on your ears, and your body has to become equalized. And as you can see, the higher you go up, the amount of mass in the atmosphere gets less and less very, very quickly. But let's take a look at that ozone real quick. Ozone is just like oxygen, all right, but it has an extra oxygen atom in its molecule. Molecular oxygen with 2 oxygen atoms combined together, that is what we breathe. Ozone has 3 oxygens, and it's super important for us because it absorbs the UV rays, at least most of the UV rays of the sun. Without an ozone layer, life on land is pretty much impossible. The UV light would actually destroy a lot of the DNA. And it is theorized early on in Earth's history, when it didn't have an ozone layer, that all of the life was basically kept in the water, where the UV rays would absorb those, or the water would absorb those UV rays. All right, let's go up to the next layer, the mesosphere. The mesosphere, or the middle layer, is between 50 and 100 kilometers high. It is the it's the least understood. And the reason for this is because it's too high for planes and balloons, but it's too low for satellites and things to study. But it is important. It is kind of cool, at least some of the things that can happen in here. First off, meteors burn up here. And other weird weather-related phenomenon can happen here. Things called sprites. Sprites are very weird forms of lightning, very poorly understood because they're hard to study. But this is a giant thunderstorm down here, and this is a picture of a sprite jumping way up through the stratosphere and into the mesosphere. You can also have another weird form of lightning called blue jets. Again, we think these go up into the mesosphere. And something called noctilucent clouds. These are clouds that seem to glow past sunset. And we don't know a whole lot about them, but they don't produce any weather, so they're just kind of cool to look at. The next layer is the thermosphere. All right. And this is really where some people start to call outer space, and not really our atmosphere, because it's such a low density that we have most of our satellites and the International Space Station inside of it. All right. This is a picture of the International Space Station, and you can see that it's black on the outside, but really it's still in the Earth's orbit, or atmosphere, just in a low orbit. For the most part, it's composed of charged particles, as the solar winds from the sun interact with our magnetic sphere, or Earth's magnetic field. It pushes the charged particles, and we'll study this with auroras, and they slam into the gases in the thermosphere and excite them and cause things like auroras. All right, this is a picture of an aurora from the International Space Station. You can see those green lights. Whoa. Here's a few of the pictures. But these all happen within the thermosphere, at least the bottom part of it. The very last layer, and some don't consider this a layer, it's called the Exosphere. And this is really where the atmosphere bleeds into outer space. There is no clear-cut line between our atmosphere and outer space. It is very, very low density. It's mostly just the lightest of the elements of gas, hydrogen, helium. And again, it's a transition layer. It goes from our atmosphere into space. The last thing that we want to mention before I leave you is what happens to the temperature. Now, most of you know that if you start going up higher in elevation, it gets colder. All right. But it doesn't just get colder until you reach outer space. All right. The troposphere, again, this is where all of the weather happens down here. All right. And what happens in the stratosphere, this is kind of an odd one. It actually gets hotter with increase in altitude. Temperature rises. And this is due to the fact that it has all of the ozone in it. The ozone absorbs those UV rays, and that converts it into heat. The mesosphere is the coldest layer. And the thermosphere is aptly named because it is the hottest layer. It gets very, very hot as the solar winds interact with our atmosphere and heats it up. So it is very important that you sketch this. One thing that you should notice is that there are certain regions between the layers where the temperature doesn't change with height. These are called the pauses. All right, and above the troposphere is the tropopause, where temperature does not change. Above the stratosphere is the stratopause, where temperature does not change with height. And also above the mesosphere is the mesopause, where temperature doesn't change. So it's very important to know these layers, what happens inside of them, what happens with temperature as you increase in height with them.